哇！冰川崩落，造起大浪，岸边的我们先跑再说。
So we have some phenomenon called calving of the glacier. Calving of the glacier is a piece of ice collapsed to the sea. Because of the melting and moving forward, the ice will kind of break and collapse into the sea. When we came 2 years ago, this calving happening maybe once a week. You can hear it like a thunder. It's like a breaking ice. We call it ice quakes actually, trigger kind of ice quake. So this calving happened once per 1 week, maybe 2 weeks. But now, after 2 years, this calving actually is every day. I mean, all the time. We even witnessed 2 or 3 times within being here, like 40 minutes or an hour.
Big wave.
快上来，快上来！
The calving can create kind of tsunami wave, which is, quite dangerous. Depends of the size of it. But obviously, when it collapses to water, we have big wave coming away. So we always have to watch it how the wave propagates along the glacier. And if there's a big one, we basically have to run because we can be flooded. We can be covered by wave. So that's why we always put our backpacks a little higher in case we cannot run back enough to pick our stuff.
这可是一次次北极探勘累积下来的经验。台湾科学家们进驻的 Cafe Ora 有8条冰川，最大的就是 Eversmart。对研究地质学的 Jack 来说，冰川消融后留下来的地形样貌还没有太多科学数据，在这里有高度的研究价值。
The ice comes from the glacier who is pushed, right? The creation of the glacier is on top. So snowing, then turns to fear and then compacts and becomes ice. When there's a lot of ice starting to move, also ductile deformation, slowly moving down until here. So top, the beginning, birth of glaciers up there. But now it's global warming, so it's melting too fast. So this feeding is not enough to come here. It's just retreating. So there will be no ice anymore. It's finished.
现在我们镜头后方看到的这座冰川叫做 Eversmart。事实上，台湾中央大学的科学家们已经连续3年来到这里观察这座冰川。而科学家告诉我们，在2年前他们看到的还没有这一座黑色的小岛，但是在现在的2年后，这座冰川已经往后移了将近200公尺。
我们看到的冰川并非全都是冰，千百万年累积下来，内部覆盖着大量沙石，靠近点就能看清。表面的冰融化后留下来的冰积物，让北极出现了冰层上的岛屿和陆地。对地球而言，就像是新的土地。
So we are looking here is kind of deformation zone. You can see really deformed rocks over there. This is Ordovician Silurian rocks that being deformed and with the strike-slip movement during this detachment of Greenland. So this piece, this outcrop here is a piece of big map that we're actually mapping now. So actually we see these wavy structures. So actually indicates the strike-slip movement. Here's a little fold, it's a Guantan. She's not really clear, but actually you can trace a little bit. So our interpretation is that this fold here was moving that direction.
Jack 观察变形的岩石构造、纹理方向，再利用定义空拍机拍摄数万张照片，记录冰川消融变化、冰雪覆盖范围的变动，以及地质构造的分布。 这正是目前地球科学领域缺少的一块拼图。
And I slowly draw a geological map. The thing is, because of glacier retreat and because of global warming, the glacier every year exposes new surface. So every year I'm coming, I have new place to research, to build the map.
搜集数据的这一天，天气不太好，北极下着小雨，但留在这里的时间有限，研究还是得做。幸好风不大，对空拍机没有太多影响。
What we do here as Taiwan team, we contribute very important part to understanding of Arctic changes, right? Because if not us, there will be nobody actually in Cachoeira, in this place. And we have a couple of glaciers, we have a lot of rivers, and we have coast. Actually, we can study. We have permafrost also. We can monitor. So this contribution is already huge because in other places there's Greenland, maybe North Canada, maybe Alaska, and maybe in Russia it's just Siberia. But this is a polar circle. It's not polar region. We are in very inner polar region. Geological map, what I do, will be very important piece of geological map that I can contribute to all Svalbard understanding.
台湾在极地研究的场域中，不再是边缘国家，科学家的积极参与，提升了台湾的国际话语权。但这一路可不容易。
来帮忙一下啊！
走，
好，我来帮你。
1、2、3，先知不对。
第一次踏进北极圈的张秉宇教授是地质专家，他从台湾扛着透地雷达进到 Cachoeira， 用雷达脉冲波探测地表下涌动层的变化。
每一个深度就放大，因为你越深的话，讯号越浅，所以我就放大。可是理论上是每一个深度应该放大一样倍率，可是你可以看到这边就反射比较强，然后同样的地方有些反射强，有些反射弱。
反射强就表示它有东西在那边。
对。
看到冰川溶解后堆满土石沙砾的表面，或是冰川前缘的苔原，以为是新大陆出现。但下方其实还是满布冰块的涌动层。
最主要是说，我们去看它的，比如说涌动层，如果我们每年做的话，就是它的变化。对。那另外就是它的分布，在冰川的前缘一直到往下到那个苔原上面的话，它整个的分布大概是什么样的一个状况？
是。
那每一年的变化大概是什么样的状况？
我们把镜头飞上空中鸟瞰，湍急的溪流是从远方的冰川前缘倾泻而下，就像是从天界流入人间，看似绝美，但却是对人类的警讯。
对啊，这个就是变成说，我们可以有一些讯息告诉我们说，永冻土在全球暖化的或者是剧烈气候的状况底下，它的冻土的消减。那这个冻土的消减代表了几个资讯，第一个是我们有多少的保存在这个永冻土里面的冰变成水嘛？那第二个是，其实这中间会有很多的那个碳会被释放出来，是，所以都可以带给我们很多的资讯。
是。
那这个释放这些碳，其实最主要是很多是以甲烷的形式，我们现在知道，所以它放出来是更加剧那个温室效应。
最热的北极夏天，正巧就被我们遇上了。根据美国国家海洋及大气总署公布的数据，2023年7到9月的北极是从1900年开始记录以来最热的一年，均温高达摄氏6.4度。只是高温记录恐怕还会继续破下去。
因为北极是一个我们讲说很多气团 在北半球的发源地，而这些气团其实是真的跟地底下的这些永冻土还有土壤的环境是完全是联动的，所以唯有这样全面的了解，才可以知道说极端气候它的可能的成因是什么。那将来我们人类还可以做哪些事情？所以每个大国竞相都是在北极设站，因为大家都认知到说这个是一切的起源。那台湾就是我们也不想说在这个整个的大家都参与的研究里面缺席这一块，因为毕竟我们可能还是相较于这些大国，或许还更脆弱，更容易受到极端气候的影响。
北极驯鹿顺应自然循环，生死都在这块土地上。但未来这块土地的环境变化，却可能对全世界的人类带来生活形态的改变。处在亚热带的台湾和北极看似遥远，但同舟一命，所有人都没有挥霍自然的本钱。